Hey guys, what's up? I'm going to look at those two problems that we didn't get a chance to really talk about in class today. The first one is this. So it says water fills a bathtub at a rate of R of t equals 1 plus 5 cosine of pi t over 10 gallons per minute on the interval 0 to 5 minutes. Okay, so it's water filling a bathtub at this rate. We need to understand that that is our rate in. I'll just do the, I'm not calibrated here, sorry about that. Okay, so that R of t then is our rate in. It's on 0 to 5. It says water drains from the tub at a rate of 2.5 gallons per minute. That 2.5 is our rate out. That rate out also applies for the interval 0 to 5 minutes. It says at t equals 0, there are 10 gallons of water in the tub. That is our initial condition. Okay, so the types of questions we could ask are how much water was added to the tub, how much water was drained from the tub, and how much water is in the tub at a specific time. And all three of those things are done slightly differently. The first question here says how much water was added to the tub in the first 5 minutes. To figure out how much water was added to the tub, we just want to integrate the rate in. And the time interval will be the first 5 minutes, so that'll be the integral from 0 to 5. Now, before I do this, I want to go and I want to enter this equation into my graph, right? Not only is this my rate in, R of t, I should add in here, this is going into my calculator as y1. My rate out, 2.5, is going in my calculator as y2. And once again, I talked about this before, but it's really important that you enter this correctly. All right, so we'll go to my calculator here. I'm going to clear what's in there. For my rate in, I'm going to have 1 plus 5 cosine fraction bar. And it's pi t over 10, so it's going to be pi x over 10. That's my rate in. Here's my rate out. My rate out is 2.5. Again, I want to set my window carefully here. I want my window to go from 0 to 5. And these rate in, rate outs don't have negative values, so I can just do maybe 0 to 10. We'll take a look at what this graph looks like. Oops, I see that I made a mistake with my window. My y min should be 0 and my y max should be 10. I'll get a better picture, hopefully. There's my rate in, graphed first. Here's my rate out, graphed second. Right away, right, I can see at the beginning here, the rate in is bigger than the rate out. But at this point in time, my rate in ends up being less than my rate out. Okay? So there's some important things happening right here. We'll talk about those a little bit later. But back to the question. I want to know how much water was added to the tub in the first 5 minutes. So I just have to integrate my rate in. And when you do that, I have a choice. I can write 1 plus 5 cosine of pi t over 10, or I can put R of t. Make the smart choice and choose to write R of t. Okay. There's no need to write out that nasty thing. Just talk about R of t, the easier version. So now I can go to my calculator, and I can do math 9 for my integral. Integral 0 to 5. And I know R of t, oops. Geez, making lots of mistakes today. Integral 0 to 5. And instead of, again, typing that thing out, I know that that R of t is stored in my calculator as y1. And I get 20.915. Make sure you go to the thousandths place. And again, this would be the amount of water, right, in gallons added to the tank. I'm noticing the top. We don't necessarily have to write out all of those things, right? But we do. It's important that we understand what we just solved for. Okay, the second part here says write an expression for the amount of water in the tub at time t. So this is our general amount equation that we need to be able to write. And on these rate in, rate out problems, it's really important we're able to do this because a lot of the questions are going to be solved by using this equation. Sometimes very obviously, sometimes maybe not quite as obviously. So the amount in the tub at any time t, I'm going to use capital A of t. And I'm going to write this as an equation, not an expression. So I know that A of t means the amount of water in the tub at time t. Again, I'm writing a general equation here, so my integrals should have t's at the top, not 5, right? That's the second part of the question. Okay, for the amount of water in the tub, we need to consider all things. Initial condition, plus the integral of the rate in, minus the integral of the rate out to find our amount. So A of t would have to be my initial condition of 10, plus the integral. And again, for my rate in, I know it starts at 0, so that's why my integral here starts at 0. Minus the integral of my rate out. Oops. Zero to t again, of the function 2.5. Again, my rate out, the reason I started that integral at 0 is because the rate out starts right away as well. If the tub didn't start draining until time 2, then my integral would go from 2 to t. Okay. So that's my general equation. Use that to find the amount of water in the tub at time t equals 5. That would be A of 5 equals, it's going to be 10 plus the integral from 0 to 5 of R of t dt minus the integral from 0 to 5, 2.5. Okay, and I'll go back to my calculator again and type that in. So I'll do math, I'm going to do 10 plus math 9, integral 0 to 5 of y1. Right, typing y1 is a lot faster than typing out that whole equation. Minus math 9, integral 0 to 5. Now it's just as fast to type 2.5 as it is y2. I'm just going to use 2.5. If you use y2, that's fine. Again, as long as 2.5 is in as your y2. I'll hit enter. And I guess I hit enter twice. And my answer is 18.415. So that's how much water is in the tub at times 5, 18.415 gallons. Again, that's not gallons added or gallons drained. That's gallons in tank at t equals 5. The next question that I want to look at is, when is the amount of water in the tub find the absolute maximum amount of water and absolute minimum amount of water. Okay, I'm going to ask both of them just to show you that it's the same process. Let's see. Okay, so to find the maximum and minimum amounts of water in the tub, right, that's an absolute max and absolute min. Absolute mins and maxes can only occur at endpoints and critical points, right? And it's amount of water in the tub, so we're using our equation A of t that we already wrote in part B. I'm going to make a t-chart of t and A of t. Now some of these values I already know. I have to check 0 and I have to check 5. Because those are my endpoints. The amount of water at time 0 was 10. And I just calculated the amount of water at the other endpoint at 5, right? And I got 18.415, I think. 18.415. But I also need to check critical points of A. And this is where a fundamental theorem of calculus comes into play. Let's talk about A prime of t. Actually, let me just rewrite A of t so I don't have to go up and down. Okay. That's my A of t equation. We already wrote that. Initial condition plus integral rate in minus integral rate out. A prime then, well, the derivative of 10 is 0. The derivative of the integral of r is r. The derivative of the integral of 2.5 is 2.5. So our amount prime is always just simply rate in minus rate out. That's all it is. In critical points, we do the derivative, right? Because critical points are when the derivative equals 0. So I want to set this thing equal to 0. Then I want to solve for t. Well, I'm just going to add the 2.5 over. And I'm looking for, when does r of t equal 2.5? I need to find that time value. Well, r of t is going to equal 2.5 when those two graphs intersect. So let's look back at our graph real quick. Those two graphs equal each other right here. So I just have to find that value on my calculator by doing the second trace, number 5, intersect. There's only one intersection, so I can just use these two. And we see that they intersect at that number. Now, what we have to do is write that full number down. Okay, I'm going to write it on my whiteboard next to me here. 4.0301332. I'm going to say r of t equals 2.5 and t equals 4.0301332. Because that's not our final answer, but we don't know if it's our final answer, we cannot round it until the end. Our final answer can be rounded. But I don't want to keep referring to that whole number, so I'm just going to let it equal the letter B. That was our only intersection, so that's our only critical point, and I need to test that. Okay. Now, watch what we do here. I want my calculator to call it B2, because that's just a much easier way to deal with it. So once we have this sitting right here, we can quit and store that answer. So hit second quit, and just hit the store button, and choose the letter B. Just take a second to make sure this matches the number that you wrote down. Okay. Now what I want to do is I need to find the amount at time B. Well, again, I just have to plug this number, or this letter, into this amount equation that I did before. Okay, so I'll just type it from scratch. We're going to have this, 10 plus math 9. Integral 0 to B. You have to hit the alpha button to get the B to show up. Alpha trace y1 x minus math 9 integral 0 to B again of 2.5. And what I get there is a value of 19.137. So those are my three different amounts that I have. So now I can say the maximum amount of water is 19.137 gallons. The minimum amount of water is 10 gallons. Okay? Be careful how the question is asked, because do they want the time or the value? If they wanted the time, we'd report B, or you could call it 4.030. If they wanted the maximum value, we'd say 19.137 gallons. If you're unsure, you can write both, right? Cover both bases. So, maximum amount of water. Is 19.137 gallons. Minimum amount of water is 10 gallons. So that minimum occurred right at the beginning. Right? Our initial condition was the minimum. Right? Here was our min. Here's our max. All right, last problem. Here's what it says. The velocity of a particle is, this is another calculator problem. The velocity of the particle is modeled by v of t equals -5 plus the quantity 2t minus 3 to the 7/5 on the interval 0 to 6. The position is modeled by x of t, and they tell us that t equals 0, x equals -3. So again, this right here is our velocity equation. This right here is our initial condition, our initial position. So I'm going to go to my calculator here. I'm going to clear out what I had in there before. And I'm going to graph that velocity equation. -5 plus parenthesis 2t minus 3 close parenthesis to the 7/5. Okay, make sure it looks good. When I do my window, the prompt tells me that t is between 0 and 6. Velocities are going to go negative, so make sure you include a negative in there. So I'll do -10 to 10. We get a velocity graph that looks something like this. I can see that pretty well here. Right? If you want to make your Ymax a little bit bigger, you can. But I like working with that. Okay, so I got it stored on my calculator. The first question says, write an equation involving an integral for x of t, right? The position of the object at any time t. Well, to find the position, I'm going to have to integrate velocity. But I have to use that initial position to do so. So here's what we have. X of t then would be my initial condition of -3 plus my integral from that t value of 0 to the t value I want of v of t dt. Once again, be smart here and write v of t. Don't write -5 plus quantity 2t minus 3 to the 7/5, okay? Now I want the position at time, specifically at time 6. Well, that's going to be really easy for me. 6 would be -3 plus the integral from 0 to 6 of v of t dt. And I'm going to do that on my calculator. I'm going to do -3 plus math 9, integral 0 to 6 of v of t, which is in my calculator as y1. And I know that my position at time 6 is 4.729. There were no units in this problem, so we don't have to worry about units. But the units would be a position unit like meters or feet or miles or inches, if there were any. The second question here says, what is the total distance traveled on 0,6? Total distance traveled is a formula that we just have to memorize. Total distance traveled will equal the integral from the time I want, or sorry, from the beginning time to the ending time of the absolute value of velocity. Okay, so it's pretty simple. So now to do this, I'll do math 9. Notice I'm not using the initial condition. It has nothing to do with total distance traveled. Just want to integrate 0 to 6. To get absolute values, we hit math, right arrow, enter. And once again, my velocity is in my calculator as y1. Sometimes the calculators, it takes them a while to spit out this answer. Just be patient. And we get 37.756. That's our total distance traveled. All right, that'll be it for this video. Watch this tonight, study over. You can watch old videos, right, as a review. If you're like, I need more rate in, rate out examples, go back and watch the rate in, rate out videos. That'll help. Watch the initial condition plus with velocity videos. Watch the U substitution videos. Lots of good ones to look over and study off of to get ready for tomorrow. Talk to you guys later. 2 chains. Bye.